Hello everyone, welcome back to Algorithm with Chelsea. Today we will learn nested for loops in Python. Let's begin. Let's quickly review list traversal. To traverse a list means we visit each item one by one. In the code on the slide, numbers is a list with 3 items, 3, 1, 4. The line 4x in numbers means x will become each item in the list in order. So first, x is 3, then x is 1, and then 4. Inside the loop, we print x. Very important, the print line is indented, usually 4 spaces. Indentation tells Python this line is inside the loop. Now, what is a nested loop? A nested loop is a loop inside another loop. Let's look at the code carefully. The first line says, for outer in a list of 1 and 2, then a colon. That means outer will take the value 1 first, and then take the value 2. Inside that outer loop, we have another loop. It says, for inner in a list of A, B, C, then a colon. That means inner will take A, then B, then C. Notice the indentation. The inner loop is indented under the outer loop, so Python knows it is inside the outer loop. And the print line is indented under the inner loop, so it runs once for every inner step. So each time we print the current outer and the current inner together, like a pair. Let's walk through the order. When outer is 1, the inner loop runs through A, B, C. So we print 1A, 1B, 1C. Then outer becomes 2. And the inner loop runs again, 2A, 2B, 2C. Key idea, the inner loop restarts for every outer step. Let's trace the variables. We use 2 lists. Numbers contains 1 and 2, and letters contains A, B, C. A nested loop means, for each number, walk through all the letters. So we are making pairs. Now, outer is pointing at 1. The inner loop starts at the beginning of letters. The code prints the pair of 1A. Outer is still 1, and inner moves to letter B. So the next print is 1B. Inner moves to C. The next print is 1C. Now the inner loop is finished for outer equals 1. The outer loop moves to the next. It points to 2. With outer equals 2, the inner loop starts over again at A. So the next print is 2A. Then inner moves to B. So we print 2B. Inner moves to C. So we print 2C. Now we see the full output. It prints 1A, 1B, 1C, and then 2A, 2B, 2C. Remember the pattern. Outer first, and inner for each outer. Now let's use nested loops with 2D list. A 2D list is a list of lists. In this example, a classroom has 2 study groups, and each group has 3 student names. Each group is organized as a list of strings. Classroom is a list of lists, and it is called a 2D list. Goal: print all 6 names in order. Group 1 first, and then Group 2. Here is the Python code for printing the 6 names in order. The input is the 2D list. Classroom defined previously. Look at the loops. Outer loop. For group in classroom. So group becomes the first group list, then the second group list. Inner loop. For student in group. So student becomes each name inside the current group. Then we print each student. Let's trace the variables. We show the 2 groups like 2 rows. Row 1. Ava, Ben, Cody. Row 2. Dina, Eli, Faye. Outer loop chooses a row. Inner loop walks across the row. In the beginning, group points to the first row. Ava, Ben, Cody. The inner loop will visit each student in this row. Now student points to Ava, so we print Ava. Student moves to Ben, and we print Ben. Now student moves to Cody, and we print Cody. The inner loop finished the first row. Now the outer loop moves group to the second row. Dina, Eli, Faye. The inner loop starts again for the new group. Student points to Dina first, and we print Dina. Next, student moves to Eli. We print Eli. Student moves to Faye. We print Faye. We have traversed both rows, and the program's ends. Now we check the output. It prints 6 lines, 1 name per line, in the correct order. Nested loops helped us print every item in a list of lists. Next, let's study how to flatten a 2D list. Flatten means to turn a list of lists into one single list. We still want the same order. Ava, Ben, Cody, Dina, Eli, Faye. Here is the Python code for 2D list flatten. The input is the same, a list of 2 lists. We create an empty list called flat for storing the results. We use the same nested loops. Traverse groups in outer loop and traverse students in inner loop. But instead of printing, we do append each student name into the list flat. After the nested loops finish, flat contains all 6 names. In the end, we print flat. Pause and guess the output. Let's check the output. It prints one list that contains all 6 names. So flattening is like collecting everything into one basket. Question 1. Flattening. We have a 2D list called grid. Its first row contains 1, 2, 3. The second row contains 4, 5, 6. The code uses nested loops and append to flatten it. What will be printed at the end? Pause and think. Check the answer. The output is one list. 1, 2, 3, 4, 5, 6. It is because we append across the first row, then append across the second row. Now we learn a very common nested loop problem. Cartesian product. That means make all pairs between 2 lists. We want results like A1, A2, A3, then B1, B2, B3, and so on. Here is the idea. Outer loop goes through letters A, B, C, D. Inner loop goes through numbers 1, 2, 3. For each pair, we concatenate the letter and number to make a new string, like A1. Now the Python code for Cartesian product. Letters is a list of letter strings. Numbers is a list of number strings. 1, 2, 3. Here, the numbers are strings, not integers. We start with an empty list called result. Then we run the nested loops. Outer loop. L becomes each letter. Inner loop. N becomes each number string. Inside the loop, concatenate L and N to make a new string, and append the string to result. After the loops, we print result. Let's trace the variables. There are 2 lists, letters and numbers. Letters has 4 strings, and numbers has 3 strings. There will be 4 times 3 combinations, which is 12. The outer loop uses L to traverse the letters. L starts at A. The inner loops uses N to traverse the numbers. N starts at 1. We combine the letter and number and get string A1. Append A1 to result. L stays at A, and N moves to 2. We append A2. N moves to 3, and we append a 3. Now the inner loop is done. The outer loop moves L to B. The inner loop starts over at 1. We append B1. Append B2. Append B3. Now the outer loop moves L to C. The inner loop restarts again from 1. We append C1, append C2, append C3. Now the outer loop moves L to D. Inner loop restarts again from 1. We append D1, append D2, append D3. We have finished the nested loop and appended a total of 12 strings to result. Now we check the full output list. It has 12 items, a 1 to D3. That is the Cartesian product. Every letter paired with every number. Question 2, also Cartesian product, and we expect exactly the same output. Look at the second line of the Python code. It is the only difference. Previously, numbers contains strings. This time, numbers contains integers. 1, 2, 3, as integers, not strings. Keep in mind that Python cannot add a string and an integer directly. So we must convert the integer to a string before combining. Fill in the blanks to make it work. Pause and try. Let's check the solution. The loops are the same, for L in letters and for N in numbers. But when we append, we use str of n to turn the number n into string. So we do. Letter plus string version of n. Question 3. Cartesian product with different order. Previously, the order was A1, A2, A3, and so on. Now we want a different order. A1, B1, C1, D1, then A2, B2, C2, D2, and so on. That means we should loop over numbers on the outside and letters on the inside. Fill in the blanks. Pause and try. Solution. Outer loop for N in numbers. Inner loop for L in letters. Inside the loops, append L plus N. Because N is outside now, we finish all letters for 1 first, then all letters for 2, and lastly, all letters for 3. Let's summarize. A nested loop is a loop inside another loop. Outer loop moves slower. Inner loop restarts every time the outer loop changes. A 2D list is a list of lists, and nested loops help us visit every item. We practiced 2 applications, flattening a 2D list and building a Cartesian product. This concludes our lecture. Thank you for watching. Please subscribe to Algorithm with Chelsea so you won't miss future updates.